Now outside the solar system. It's beyond the orbit of Neptune. Its carrier is a 1-watt signal, and that is about 1/20th of the energy of a candle burning. So we're picking up a really small signal indeed, if we succeed.
The NASA effort has united Barney Oliver and other longtime SETI proponents with a younger generation of computer builders and programmers, including Kent Cullers, who, despite being blind, has worked on the statistics of pattern recognition.
The Pioneer 10 is simply a very good example of the kind of signal that we might detect. First of all, although it's kind of close in interstellar terms, it's very weak. One would expect that a civilization would be farther away and stronger. It's near the limit of our detection. It's also a good example of a signal that might be used as a beacon.
20 words. I'm going to go up a hertz. Just let's see what happens, Peter.
The test was successful, even though the rotation of the Earth and its motion through the galaxy continuously changes the frequency of Pioneer's signal over time.
There's a promising candidate right here. We'll have to wait for a few more spectra to see if it... Yes, I think that's it. This bright line that you see going slanting down the screen is the signal from the Pioneer 10 spacecraft.
Now, if you look at other means of communication or making contact, you have to send something. You can't just think about it. You have to send something. And we've investigated all the known particles, and it's certainly true that electromagnetic waves or photons are hands down the best medium to use.
So it might seem that we have solved the problem of how to do the SETI experiment. Look for artificial signals at radio frequencies. Unfortunately, it's not that simple. Consider a terrestrial FM radio dial. On Earth, we recognize the channels of our favorite radio stations, defined in megahertz, and can tune from one to the other. Each station has an assigned place on the dial. There, it broadcasts a carrier wave that's always present, no matter the program content. The stations are separated from each other so that they do not interfere. On the cosmic radio dial, we're also looking for signals artificially concentrated in frequency. But we don't know what frequencies the extraterrestrials may be using. On Earth, between 90 and 92 megahertz, there are just 10 frequencies in use. On the cosmic dial, there are 20 million potentially usable frequencies. In space, the entire electromagnetic spectrum could be used for communication. But in practice, some portions of the cosmic radio dial are harder to use. Lower frequencies that we use for FM and TV broadcasts are overwhelmed by interference from natural sources in our galaxy. So we think it makes sense to listen in the microwave region, between 1,000 and 100,000 megahertz.
There is a preferred region in the electromagnetic spectrum, we believe, that minimizes the energy required to make contact, and that is in the microwave region. And the reason for that is that the noise that would interfere with our transmissions, or theirs, is lowest there. If you go lower in frequency, the noise increases from noises that the galaxy produces. If you go higher in frequency, quantum effects come in and create noise. And in this silent valley between those two walls, communication can be accomplished with the least energy of any region of the spectrum.
But even if there are clues about frequency, you still must choose where, when, and exactly how to listen. It's really more like looking for a needle inside a haystack. For simplicity, SETI researchers compare their experiments using 3 parameters. In addition to frequency, you have to choose directions, to survey the whole sky, or to target individual stars. And all experiments will have different sensitivities, determined primarily by the size of the radio antenna and by how long they listen. Are there any further clues which can help limit places to look for the needle? Many SETI researchers think there may be, at least in the frequency dimension. Since hydrogen is the most abundant element in the universe, they argue that all intelligent species would think of transmitting their signals close to the frequency at which hydrogen atoms naturally emit radio waves. 1420 megahertz was the first so-called magic frequency to be tried. It was at 1420 megahertz that Frank Drake searched in 1960, the first targeted search. He looked at just 2 stars at this one frequency in a search of moderate sensitivity. In 1973, Ohio State University, with its unusual antenna, began a continuing sky survey. It listens not to single stars, but to the sky passing overhead. It covers 50 channels, but is low in sensitivity. Searches over the last 6 years by myself and French radio astronomer François Biraud at Nancy have looked at 350 stars in the latest targeted search. There has been significant international interest in SETI, with searches mounted in the USSR, Canada, Holland, Germany, and Australia, as well as those in the United States and in France. At Nancy, by adapting existing radio astronomical equipment, we've been able to listen to thousands of channels simultaneously. We've achieved improved frequency coverage and a modest gain in sensitivity. As computers advanced, it became possible to construct detectors that were specially adapted to the needs of SETI. One of the first researchers to take advantage of this capability was Paul Horowitz, a professor of physics at Harvard University. The key breakthrough was the ability to scan many channels and frequencies simultaneously. The heart of the system is a so-called multi-channel spectrum analyzer, or MCSA. The one Horowitz uses in his latest system was designed in collaboration with Ivan Linscott and colleagues at Stanford University as part of the R&D for NASA's planned SETI system. Horowitz puts this equipment to practical test in a sky survey known as META, the Mega-Channel Extra-Terrestrial Assay. Drake's experiment could scan only one frequency channel at a time. META can listen to 8.4 million frequency channels simultaneously. It can do in 1 second what took Drake 5 years. META, funded by the Planetary Society, is perhaps the ultimate magic frequency machine. But if Horowitz has guessed wrong, he may be looking in the right direction with excellent sensitivity, but just the wrong frequency. No search to date has found any evidence of intelligent life, but SETI researchers feel that their equipment has not been equal to the task. NASA's goal is to extend these previous efforts into a truly comprehensive search. Successful tests of hardware and software in detecting signals like those coming back from Pioneer are but the first steps in a planned 10-year project that will combine the most promising strategies from these earlier searches.
The NASA approach that we're developing right now has two different approaches to the search, and they're complementary. One of them is called the Sky Survey, and another is called the Target Search. And the objective of the Sky Survey is to search the entire sky, making no guesses as to what are the best directions. To carry out that search in a reasonable length of time, we have to do it quickly, which means we sacrifice sensitivity to signals. We only detect maybe the strongest of the signals that might be there.